Hey guys, welcome back to the channel. Today we are going to solve this interesting problem on permutation and combination. Before we begin, let me equip you with the formal wording of this question. A six-sided convex hexagon are colored red, means each side of this hexagon are colored by red only, and each of the diagonals of the hexagon is colored either red or blue, means diagonals are colored either by red or blue, and n is the number of colorings such that every triangle has at least one red side. The triangle which is formed by joining these vertices has at least one red side, and we need to find the sum of squares of digits of n. Pause and try it for 2 to 3 minutes and then move to the solution. I hope you have given it a fair try. So let me move to the solution. Before we move ahead, we need to find the number of diagonals in a hexagon, which is 6e2 minus 6. 6e2 means total number of lines which are formed by joining any 2 points. Because selecting 2 points means is equivalent to counting one line. Minus 6 means we need to subtract those adjacent sides which are counted in the process of 6e2. Then 6e2 is 15 minus 6 is 9. This means total number of diagonals in a hexagon is 9. Or we could do that in a brute force way. Consider a triangle A1, A3, A5. This is formed by joining 3 diagonals. 3 of them are here. And the next triangle is A2, A6, A4. 3 of them are here. Then it becomes 6. And A2, A5 and A6, A3 and A1, A4. Then 6 plus 3, it become 9. Then that way we could also arrive into the answer. So we are going to use a technique called complementary counting, which means that we have to find the total number of cases first, and then we subtract those cases which are not there in the solution. I will explain this. Considering the triangle A1, A3, A5 and A2, A4, A6, these are triangle which violates our condition. We need to find triangle which has at least one red side. We chose this because we have using a technique called complementary counting, which means we need to subtract these cases from total number of cases. That's how we arrive to the answer. Then we need to consider a event where selecting this triangle A2, A4, A6 as event 1 or E1, let's say. Then remaining diagonals, there are 6 of them are here. Why? Because total 9 of them are here. We selected 3 of them were we selected. So 6 of them are here. Each diagonal has 2 possibilities, either by giving blue or red. Then we need to select 6 of them. That means 2 into 2 into 2 into till 6 of them, which gives us 2 power 6 as the total number of possibilities. Then if we consider A1, A3, A5 as a blue triangle, then the total number of ways to draw the remaining 6 diagonals are 2 power 6. And then if we choose a case where considering the 2 blue triangles A1, A3, A5 and A2, A4, A6. If we choose both the triangles, then the number of diagonals remaining are 3. Only 3 because each triangle occupy 3 diagonals like this. Then remaining 3 of them are here. So 2 power 3 ways to color the remaining diagonals. If we take union of these two events, E1 and E2, means selecting the triangle A1, A3, A5 or A2, A4, A6, then it become 2 power 6 plus 2 power 6 minus 2 cube. This is from De Morgan's law. Then we ended up getting 64 plus 64 minus 8, 128 minus 8, which is 120. And then we use the complementary counting technique. We subtract this 120 from total number of cases, which is 2 power 9, which is 512 minus 120, 392 as the total number of ways to select the triangle which have at least one red side, and our n becomes 392. We need to find the squares of digits of n, which is 3 square plus 9 square plus 2 square, which is equal to 9 plus 81 plus 4. We ended up getting 94 as the final answer.